We're now going to turn our attention to how we can use percent values as conversion factors in dimensional analysis. Percent values, otherwise known as PPH, and the PPH stands for parts per hundred, are calculated by taking the part, whatever it is that we're interested in looking at, and comparing it to the whole or total of which that part is contained. And the hundreds comes into play because then you multiply by 100 to convert it into a percent. Notice the percent sign is a unit that is attached, indicating that this is a percent value or a PPH. You can compare PPHs with other ratios known as ppms, parts per million, or ppbs, parts per billion. These two unit expressions would be found where the ratio of the part to the whole is so small, you're looking at such a small ratio, that you either need to multiply by 1,000,000 to get a reasonably sized number, hence ppm, or you would need to multiply by 1,000,000,000 to get a reasonably large number. So ppm and ppbs are used whenever the ratio of the part to the whole is very, very small. In Chem 2A, we most commonly will be working with PPH as in parts per hundred. We will be working with percent, PPH, parts per hundred. A very common type of a very common type of percent value that we use in Chem 2A is mass percent. It's a common percent, but not the only type of percent value that we use. So mass percent would be the ratio of the mass of a part to the mass of the whole or total multiplied by 100%. And I'll illustrate this concept of mass percent in the problem shown below. So what we really want to focus on now is how we can write mass percents as conversion factors, hence the title of this section. We must be able to use mass percents as conversion factors for problem solving using dimensional analysis. So here is a problem that illustrates this. Pacific salmon, a type of fish, I enjoy it very much. You, I hope, do too, or have had it and enjoy it too. Pacific salmon contains 1.9% biomass omega-3 fatty acids. Now, omega-3 fatty acids is a very beneficial type of fatty acid associated with lower risk of heart disease. So the question here is, what is the total mass in grams of omega-3 fatty acids contained in 24 Pacific salmon? And we're going to assume the average mass of an adult Pacific salmon is 9 pounds. So how do we go about solving this problem? Well, we need to come up with the necessary conversion factors, starting with that very important mass percent that was presented at the beginning of the problem. We're told that Pacific salmon contain 1.9% omega-3 fatty acids by mass. How do we write that as a conversion factor? Well, you take the number associated with the percent. The percent sign literally means out of 100. So we're going to take that 1.9 and put it over 100. It's that simple. To write a mass percent or any percent value, for instance, you take the value that's given with the percent sign and put it over 100. Because this is a mass percent, we need to use mass units. Well, what mass units do we use? And the answer is whatever mass units you choose that are appropriate to the problem, as long as they are the same numerator and denominator and cancel out. Now, I wrote this conversion factor using grams, but I'm explaining to you that I could have erased the gram unit and put pounds in place of that. As long as you use the same unit numerator and denominator so that it cancels out. Percents are one of the few unitless numbers other than just the percent sign itself. So you choose the mass unit, which is appropriate to the problem. Since I'm asked to express a final mass in grams, that's why I chose to use gram units for the mass percent. But again, that is a choice. Once you write your conversion factor, 1.9, again, 1.9 grams of omega-3 fatty acids per 100 grams of salmon. Note how I've labeled those values. It doesn't do any good, or it's limited use, to leave those labels off, because then you're not sure whether or not you need to use the conversion factor as written or in its flipped form. So the labels are very helpful in telling you which way or how to write the conversion factor in the setup. So I'm going to write those labels back in, and I recognize that if needed, I can take that mass percent and write it in its flipped or inverted form in my setup. So this is the procedure by which we would write a percent as a conversion factor. What other information is contained in this problem? We're told that we have 2 dozen salmon, and the understanding is that dozen is a very common unit associated with 12. So there are 12 salmon in 1 dozen, and we need that conversion factor in this setup. We're also told a relationship between the salmon size. 1 salmon has a mass of, on average, 9 pounds. So I can write that conversion factor here, 1 salmon, average mass, 9 pounds. And then I'm asked to solve for the number of grams of omega-3 fatty acids in 2 dozen fish. So my starting point here is 2 dozen salmon. I'm going to use the relationship between 1 dozen and 12 to convert from 2 dozen to the total number of salmon that I have present. So if I stop my setup right now, my dozen units cancel, and I know how many total number of salmon I'm looking for. But I'm trying to get to grams of omega-3 fatty acid. Well, omega-3 fatty acid is related to grams of salmon, not total number of salmon. So I'm going to have to get from salmon count to mass of salmon. Here is a relationship I can use. 1 salmon has a mass of 9 pounds. I see that I need my salmon unit to cancel, so I am going to take this conversion factor, 1 salmon has a mass of 9 pounds, and write it in its inverted form. 9 pounds to 1 salmon. According to the dimensional analysis, if I stop my calculation right now, I know the total mass in pounds of 2 dozen salmon. But in order to get to omega-3 fatty acids, I'm going to have to convert from pounds to grams. My conversion factor here is showing in grams. So I have memorized the relationship between grams and pounds. It's not stated here in this problem. You need to bring that information that you memorized to this setup. 453.6 grams to 1 pound. And of course, we're talking here grams of salmon. So I can just throw that in here, grams of salmon. If I stop my calculation at this point, I have found the total mass in grams of 2 dozen salmon. Now I'm ready to use this mass percent as a conversion factor, which relates the mass of salmon in grams to the amount of omega-3 fatty acids present in the salmon. So I can use it in two forms. I need my grams of salmon to cancel, so I am going to choose this form here, where grams of salmon is in the denominator. I do not want to use it in its inverted form for this calculation. And I will multiply 1.9 grams of omega-3, make that line a little more horizontal, fatty acids to 100 grams of salmon. If I look at my setup, my grams of salmon have canceled, and bingo, I have grams of omega-3 fatty acids showing as my final unit exactly what I am asked to solve for. So the dimensional analysis, the unit operation, is telling us we have achieved the goal and solved for grams of omega-3 fatty acids. What's left is to operate on the numbers in the setup and double check our answer. So I'm quickly doing the calculation. I hope you are doing it along with me and double checking. I actually double checked this answer before I started, and so I am simply going to put up on the board right now what my calculator is displaying. 1861.57 ... Again, most of those digits are not significant. So let's evaluate the sig figs. 2 dozen is an exact count. Sig figs do not apply. 12 salmon in 1 dozen, again, an exact count. Sig figs do not apply. The average mass of 1 salmon is a measured value. Sig figs apply to measured values. We have 2 sig figs. The conversion between grams and pounds, English to metric, is not exact and has 4 sig figs. When we come to the mass percent, the sig figs are found with the decimal number associated with the percent sign, meaning the 100 is exact. We wrote that from the percent sign, and the decimal 1.9 is a measured value. It has uncertainty, 2 sig figs to that. Looking at our calculation, multiplication, division, our answer can have no more than the smallest number of sig figs used, which is 2 sig figs. So the uncertainty here is in the hundreds place. And if we use rounding rules, since what comes after the 8 is greater than exactly 500, we need to round that 8 up to 9 and express our value in scientific notation. 1.9123 times 10 to the third grams of omega-3 fatty acids in 2 dozen fish. 1.9 with 2 sig figs times 10 to the third, so 1900 grams of omega-3 fatty acids present in 2 dozen salmon.